Hey everybody, in this video we are going to kind of do a little evolution going from when you use plus minus and find all possible answers, when you only get one answer or one output, and how that kind of ties in and correlates to trig inverse as well. And then we're going to get into my handy dandy heart chart, okay? So let's get started. Here in this first set of examples, we're going to solve for x. So x is already basically solved for. We're just going to finish. So this is just going to be x equals 2 because all I have is the positive square root. Whereas the next one, I'm going to get x equals negative 2 because it's only asking me for the negative square root. Here, when I'm solving myself, I'm going to take the square root of both sides. And when I am the one to take the square root, I use plus minus. On the left, I have x equals. And on the right, I really have plus minus the square root of 4, which ties in to giving me both answers, plus minus 2. So here I'm taking square root myself, so I just put all possible answers. Whereas in the first two, it was already there. I'm using the function operation and just getting the single output. Now for trig inverse, same idea. Sine inverse of a half, the way you read the question is just like up above, right? The way you read square root of 4 is what number times itself equals 4. Because squaring, you multiply something by itself, right? So you have to learn to ask yourself the question, sort of turn it inside out. So down over here, the sine of what angle equals 1/2. And then where do we go looking for that angle? Just like here, I only wanted the positive square root of 2 because, well, it's positive square root. So down here, if I want to look for the sine inverse of a positive, we just did in the last video the range for sine inverse. And the range for sine inverse was from negative pi over 2 to pi over 2. And what does that look like sort of visually? Well, visually, that's going to look like the right side of the unit circle. Your initial side is here. Positive pi over 2 is here at the top, and negative pi over 2 is here. No, we're not going around that way and going toward like 3 pi over 2. Not at all. We're only coming from the initial side and sweeping clockwise to get where sine is negative, or sweeping counterclockwise to get where sine is positive. And we're only going to get answers here on the right side. So where on the right side is there an angle that when I take the sine of that angle, I get 1/2? That angle would be pi over 6, and you're done. Whereas here in the one right after it, sine of what angle is negative 1/2? Well, same idea, it's going to be down over here, and the angle would be negative pi over 6, and that will be the angle theta, right? Then here in this last situation, I'm taking sine inverse myself of both sides. I take sine inverse here, gonzo, I just have theta. And I take sine inverse of a half. Now I'm taking it myself. So is the answer like what I got in the first part on the left in this row, just pi over 6? No, I'm going to label that. I'm going to indicate that. And this location where 5 pi over 6 is, and every single coterminal angle to those. So really, the answer to this last question, I'm just going to erase this mess so I don't have to rewrite it all, right? So use your imagination to keep up right now, or, pause, copy, whatever you need to do. You're going to get not just pi over 6 plus 2 pi n, where n is an integer, but we're also going to get quadrant 2, which is 5 pi over 6 plus 2 pi n, where n is an integer, which maybe we write like this, right? Something like that. So these two equations would indicate all the possibilities, every single one, every possible answer. All right. Now, if the direction said, oh, just solve between 0 and 2 pi. Okay, well, then I'm just going to mention those two. I'm not going to write my general solution with plus 2 pi n. All right, so that's what's going on. That's what the whole discussion around trig inverse is so confusing for people. So you have to pay attention. Was the inverse sort of typed on the question already and given to you as a function? Or are you taking that inverse and in that case finding all possible answers or all possible answers in the area, being described? But over here, I have what I like to call my heart chart. Now, if I'm talking about sine, all right, sine, or really sine inverse. I'm going to be describing positive sine inverse of a positive ratio is here between 0 and pi over 2. And then sine inverse of a negative ratio is down here between negative pi over 2 and 0. The same will be true for its reciprocal cosecant inverse. It will also be here and here, I promise you. What else do we have? Well, how about cosine inverse? Cosine inverse, I'm looking up here now. Here it is. If I'm looking for cosine inverse of a positive ratio, I'm going to look in this quadrant to get my outputs, my angles between 0 and pi over 2. But for my cosine inverse of a negative ratio, I'm going to look over here. Why can't I look over here? Well, because cosine's not even negative here. Cosine's positive, right? So that would be useless. And why can't I look for sine in the top left? Well, sine's positive there. Sine and cosine behave differently. They're positive and negative in different places. We also don't want to pick anything over here because that would mean our inverse function's graph will be disjointed. And we don't want to deal with that, right? You don't want to have a piece of, like an intentionally piecewise looking function. Who wants that, you know? Maybe you love a piecewise, but why would you go, there and there for anything? It's kind of silly. So nobody is here. Think of that. That's District 13. Nothing is going to be over there. Now, secant and cosine, we're going to look in the same places. We're going to look over here in between 0 and pi over 2 when I deal with a positive input ratio to get my output angle. And I'm going to look over here in essentially quadrant 2 between pi over 2 and pi when we have a negative input ratio. Okay? As for tangent and cotangent, I promise if you Google and you look online, there's more than a 90% chance that the cotangent inverse information you're going to find is wrong, okay? I'll get into more detail in another video. My dog is barking like crazy. I don't know if the noise canceling is getting him out, but I'm just going to try to wrap this part up here, talking about this chart before in the next example video. I'm going to do a lot of problems using this chart, but if I want tan inverse or cotan inverse of a positive ratio, like all of them, we look over here. Cotan inverse of a negative, we're looking here. But tan inverse of a negative, we're looking here. So there's 3 in each quadrant. So cotan and tan, not only are they reciprocals, but they're also cofunctions. Maybe they spend too much time together. So when things are negative, they're a broken heart. They got to be in separate rooms. I hope that this helps you kind of visualize where you're going to go looking for your answers when you're dealing with the trig inverse function. And check the next video for applications using trig inverse and compositions involving trig inverse. And I hope this was helpful. If so, thumbs up. If not, go ahead and give it a thumbs down. And adios for now. Bye.